I want to do one more example problem of this normal distribution. So this is page 419, and we're doing numbers 5, 6, and 7. So according to this 9monthsafter.com, I'm a little nervous about this .com and the validity of the information, but whatever, I haven't checked it. We could go check it out and see if it seems legit. So according to this website, the lengths of human pregnancies are normally distributed with a mean of 268 days and a standard deviation of 15 days. So because it says it's normally distributed, we can use this normal distribution plot to calculate a bunch of different probabilities. So remember where the mean goes. Our problem said the mean was 268 and the standard deviation was 15. That goes exactly in the middle, and then we're going to add that 15 to get the upper standard deviations, the plus ones, and we're going to subtract to get the lowers. So 268 plus 15 is 250. What? That's a minus. 268 plus 15, let's see, 8 plus 5 is 3, carry a 1, so 283. All right, the next one is 298. And the final one, let's see, we take 2 from the 5 to make that a 10, so it's 0. No, it's a 3. What? And then 11, so what, 313? Yeah. Whew, that was difficult for me. And then we subtract to go this way, so that was the one I had there, 253, and subtract again. Boy, I'm going to stop embarrassing myself and use a calculator. Stop laughing, I hear you all. And then one more, 223. Okay, so these are the lengths in days of pregnancies. So our first question says, what's the probability that you were born more than 290 days after you were conceived? Well, we go to our standard deviations here and we see where our 298 is. And since it says after, that means above. So we're looking at these areas. Based on the graph above, we know that's 2.2%. This is 0.1%. So our answer for number 6 is 2.2% plus 0.1%. That's about 2.3%. There's a 2.3% chance we were born above that. By the way, don't round these numbers. These values from our normal curve are approximations already. All right, this says if a child is conceived on April 19th, oh, good gracious, what is the probability that we'll be born on or before January 27? Okay, this is a hateful problem because we have to sit here and figure out how many days are there between April 19 and January 27. So let's try a trick here. I'm going to go to Google and say how many days are between and January. What? January, yeah. January 27. Hey, there we go, 283 days. So that made it easier than trying to calculate all that mess. So the question here is, what's the probability it's more than 283 days after a child was conceived that they would be born? Well, since it's, let me read that again. It says on or before. So we want less than 283 days. That means we're going from here back. So I know that all of this area right here, all of that's 0.5 because that's below the mean. And I then know that this area here is 0.341 from above. So 0.5 plus 0.341 is equal to that chance that a baby will be born in 283 days. So it's a probability. You could write it as 0.841 chance, or you could say there's an 84.1% chance a child will be born in 283 days.